Hi, I am researcher Nai. Generally speaking, our concept is that the memory of an event becomes blurred over time. After some time, we will not be able to remember the event or its details. But have you ever experienced two similar events in a very short period of time, such as going to two beaches for swimming, or two birthday parties of your friends? At first, when you think about these two events, you will not be able to tell in which event a minor thing happened, as if the two events are almost the same. But when you think about them again after a while, something will pop up in your mind and you will be able to distinguish the details of the two. Why is it so? To answer this question, researchers designed an experiment. First, a group of mice were brought to move around in an experimental environment, and while they were moving, several times of electric shock were delivered to them. Then, after an hour, the researchers ran a recall period. The mice were first brought to a neutral environment that was similar to the experimental environment but with different details. After a while, they were brought back to the original experimental environment. The mice were not shocked again during the recall period. Later, the researchers further ran a recall period each after 5 hours, 12 hours and 24 hours to observe how the behavior of the mice changed over time. The researchers found that during the initial recall period, regardless of whether they were in the neutral environment or the experimental environment, the mice were all frozen and didn't dare to move, as if remembering that they would be shocked should they move around there. But when the mice revisited the neutral environment and the experimental environment after 12 hours, they behaved differently. They began to move around in the neutral environment, but still didn't dare to move in the experimental environment. It seems that the mice were able to distinguish between the two environments, remembering that the neutral environment wouldn't deliver electric shocks and the experimental environment would. How can we explain such observation? Throughout the course of the experiment, the researchers had been monitoring the activity of neurons in the hippocampi of the mice's brains, and these are the neurons responsible for forming memories. The researchers found that when the mice were first shocked in the experimental environment, a group of hippocampal neurons was activated at the same time. So this group of neurons was identified as the memory trace or the engram of such event, and by activating it the memory of the event could be recalled. During the subsequent recall periods, each time when the mouse visited the experimental environment, this group of neurons was reactivated, indicating that the memory of being shocked in the experimental environment was being recalled. However, engrams are not static. Over the course of time, in the later recall periods, when the mice visited the experimental environment, the portion within this group of neurons that could be reactivated was significantly reduced, but it seems the mice's memories of being shocked were not impaired. This shows that the number of engram neurons corresponding to being shocked in the experimental environment was shrinking. On the other hand, during the initial recall period, when the mouse visited the neutral environment without being shocked, another group of hippocampal neurons was activated, forming yet another engram corresponding to the event. The researchers found this engram of not being shocked in a neutral environment and the initially formed engram of being shocked in the experimental environment, as discussed above, were highly overlapping. That is, the neurons involved in the two engrams were largely the same. The reason may be that the two environments were similar. Likewise, the number of engram neurons corresponding to not being shocked in the neutral environment shrank over time. Moreover, the degree of overlap between the two engrams was also greatly reduced. That means the neurons that should be activated to recall each of the two events were already very different. This explains what we saw. Initially, as the two engrams were highly overlapping, both events were recalled with the activation of almost the same batch of neurons, so what the mice recalled would be very similar, including memories of the experimental environment and the neutral environment. They couldn't tell the difference between the two and thought they were the same environment, so they didn't dare to move wherever they visited because of the memory of being shocked. But later, when the two engrams no longer overlapped, what the mice recalled would be different. They became capable of distinguishing between the experimental environment and the neutral environment, identifying the neutral environment as safe and so were brave enough to move around inside. From this experiment we can conclude that our memories are also likely to become clearer or stabilized over time. When we first encounter an event, we will recruit a batch of neurons to remember it. Since initially we don't know the appropriate number of neurons needed to remember the event, we will tend to recruit more neurons. So, if we are to remember another similar event within a short period of time, the neurons we recruit may be highly overlapping, resulting in our inability to distinguish between the two events. However, over the course of time, each time we recall either of these two events, the brain will exclude some of the neurons originally recruited but actually are not needed to participate in the memory of the event, and stop reactivating them. That means we will use fewer and fewer neurons to remember the event, and the neurons involved in remembering the two events will no longer be highly overlapping. Hence we will gradually be able to distinguish the two. Therefore, the number of neurons used in a memory is not necessarily the more the better. As long as it is enough to recall properly, the fewer neurons involved the better. In the future, when you are not sure whether you did something at home yesterday or on the day before it, why not wait for a while, and you will remember it when you think about that after some time. Please continue to stay tuned, and together we will further explore the amazing world of neuroscience. Bye.